to my Learn DSA YouTube channel. In the previous video, I have completed two sorting methods. So today I will discuss about graphs in nonlinear data structure. What is a graphs? Graphs is a nonlinear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes and the edges are lines or arcs that connect any two nodes in the graphs. More formally, a graph is composed of a set of vertices and a set of edges. The graph is denoted by V and E. So we can see vertices and edges in this given example. So what is the vertices? Vertices are the fundamental unit of the graphs. Sometimes vertices are also known as vertex or nodes. It is possible to label or not label each node or vertex. So what is the edges? In a graph, edges are used to draw connection between two nodes. A directed graph's ordered pair of nodes can be found there. Any two nodes can be connected in any way by edges. You can label or unlabel every edges. So this is the vertices A, B, C, D and E. So this is the edges. Next I will explain about how many vertices and how many edges are in this given example. So there are 7 vertices are in the graph and 10 edges are in this graph. So P, Q, R, S, T, U, V are the vertices. So these are the edges. Next I will talk about graphs application. Social networks, web graphs, geographic information system, recommendation systems, computer networks, molecular biology and bioinformatics, knowledge graphs. So next I will talk about types of graphs. So there are so many graphs in the data structure. Here we can see some example of the graphs in this slide. Undirected graphs, directed graphs, unweighted graphs, weighted graphs, cyclic graph, acyclic graphs. Next, I will show you some example of different types of graphs. You can see the different by looking at each of these graphs. So, in this video, I will discuss about directed graph and undirected graph. First of all, I will discuss about undirected graph. Undirected graph is the types of graphs where the edges have no specified direction assigned to them. So there are two methods used to represent a graph. First one is adjacency matrix and adjacency list. So I will discuss about represent and undirected graphs using adjacency matrix. So this type of graph is called an undirected graph. It can go from A to B and B to A. So no direction are shown in these edges. First of all, you need to see how many vertices and how many edges are there in this graph. So 5 vertices and 6 edges are in this graph. So I hope to represent these graphs as an adjacency matrix. Then the matrix can be taken care of in this way. In this way, A, B C, D and E. Vertices have been left as column rows. The size of the matrix has to be created according to the number of vertices. You can start anywhere on these graphs to fill this matrix. Let's start with A. From A, there you can go to B and D. Here are these two places. These are two places where we can go. We put 1 in those place and 0 in other place. This is how the first row is filled in the adjacency matrix. In this way, after filling each row, you can get an adjacency matrix. So I hope this is very clear to you. In the next example, I will explain to you how to draw the edit matrix when there is a self loop. So this is a self loop. In this graph, there is a self loop from D to D. Add 1 to D to represent in the matrix. Next, I will talk about directed graph. What is mean by directed graphs? A directed graph is defined as types of graphs where the edges have a direction associated with them. So next I will talk about represent and directed graphs using adjacency matrix. So it is called a directed graph because this edges has given a direction. You can go from 1 to 4 and because the arrow is in the direction of the 4 digit. But you cannot go from 4 to 1. You have to consider the direction of the arrow. There are 5 vertices in this graph. They are considered 0, 1, 2, 3 and 4. And the links between them are considered as edges. There are 6 edges in this graph. So let us now draw the adjacency matrix according to this graph. If we consider 0 first, it can go from 0 to 1 and 0 to 2 because there is a direction. Then in the row called 0, 1 is put for 1 and 2 and 0 is put for everything else. In this way, all vertices can go there. See the direction and fill the adjacency matrix. When we consider this matrix, only 4 can go in the row called 3. That's why it's called this one and it's represented by a row. Next, I hope to talk about how to construct an adjacency matrix from a weighted directed graph. So considering that vertices only B can go from there. A weight is given to go from them to B. The graphs which have a weight of 4 are called weighted graphs. Now let's see how to make an adjacency matrix by using this weighted graph. If we consider that row as in the previous example, only B can go from there. Then if a weight has been given between A and B, that weight will be shown in the adjacency matrix. In this adjacency matrix, you have to put the weight corresponding to the direction you can go and put 0 for everything else. In this, how a weighted graph is converted into an adjacency matrix. So thank you. Please subscribe my YouTube channel and share with your friends. Bye bye.